Okay friends, welcome back. In the previous session, we have completed Z-Transform and there is a small topic which is related to Z-Transform which is nothing but system realization. Okay. So you might know in the control system how to realize a continuous time system. Here we will see discrete time system. So that is where in the continuous time we have used the Laplace transform. So here we are going to use the Z-Transform to construct a system. Okay. So here construction means we don't have to worry about much. So we have to simply see what is a block diagram representation for a given transfer function, and if a block diagram is given to you, how to convert that into transfer function. So these are the things what we have to see now. So let's see first we will see continuous time case, which is not our concern actually, but to make you understand what is a discrete time system, first I will go with the continuous time system, then I will go into the discrete time case. Okay. First, what do you mean by system realization? System realization is nothing but block diagram representation of a discrete time system. Okay, so I am writing that point here. System realization. Block diagram representation block diagram representation of a discrete time system. So in this system realization, actually continuous time also there, but in our syllabus we are having discrete time. Okay. So here system realization having so many techniques. So in that method, first one, direct form 1, second one, direct form 2, third one, series connection or cascade connection, fourth one, parallel connection. Parallel connection. So, but in our syllabus, we are having direct form 2, but we will see most of them direct form. So, this is what the syllabus. So, it is also called as canonical form of representation, or sometimes why it is very prominent direct form 2 is it requires less number of elements, or we can say the construction requires less number of elements direct form 2. So that's why this is more prominent than the other methods to realize a discrete time system. I hope you understood. So first take down this, then we can see. Now let's say direct form 1, direct form 2, so that you can understand what is the advantage of direct form 2. Direct form 1. To make you understand, first I will go for the continuous time case, how we can represent a transfer function by using a block diagram. From that, we can again come back to direct form 1. Okay. So let's say first in the continuous time case, this is not required for us, but just to make you understand only. Suppose a transfer function h of s is given like this, b0 plus b1s plus b1s. So this transfer function I want to realize. That means I want to show it like a block diagram. Then how can we show this? Try to understand. Can I show it like this? First, So here x of s is there, here y of s is there. Yeah. First b naught, x naught multiplied with b naught is equal to y. Next, multiplied with s, multiplied with s. Then we are having multiplication factor b1 by adding 1. Next, we require s square b1. So again, if I include one more s, let's say b2. Then, if you observe carefully, b naught plus b1s plus b2 into this is a 2s is there, s, so that is going to be s square. So this is going to create a transfer function which is in the form of b naught plus b1s plus b1s square. I hope you understand. So here this block is called as forward block. This block is called as forward block. Forward block. So why forward block is used? Forward block is used to create a transfer function which is in this form. What is this form? Actually, if you equate it to 0, this will become 0. That means forward block represents 0. That's for the meaning of it. It represents 0. Forward block represents 0. Or sometimes it is called as zeros block. Zeros. Now let's say one more thing. Suppose h of s, which is like this, 1 by 1 plus a1s plus a2. I want to represent this one. How we can represent this? Let's say. Actually, better we will go with a somewhat smaller thing so that we can understand well. This 1 by 1 plus a1s. This can be written as 1 by 1 minus a1 into, I can write it. See why I have written this. Let's say you might have positive feedback. What is a positive feedback system? G of s h of s. This is a positive feedback system. For this, what is the transfer function? Transfer function is nothing but g of s by 1 minus g of s into h of s. This is the transfer function what we are going to get if it is a positive feedback. If it is a negative feedback, then we are going to get plus. So this is what we know from the control system. So I am just going with this one, let's say. So here 1 minus this one. So here can I take g of s is equal to 1? So if I take g of s is equal to 1, so then it is going to look like 1. And for this, let's say if I take s here and here, the multiplication factor what I am taking is minus a. This one. This block indicates this transfer function. Why? So see this. 1. What is the transfer function of this path? This is nothing but minus a1s. And it is a positive feedback. So it is going to be 1 minus of minus a1s. Which is going to give you this one or not? Yes, definitely it is going to. So in short, what we can say, this block is called as feedback block. Suppose if I am having one more term, let's say a2 s square, then that is also can be written as minus of, let's say, plus minus a2 s square. A to S. So here I can insert one more S, and in the reverse path I can write minus A minus A. So this is called as feedback block. This is called as forward block. This is called as feedback block. This is called as feedback block. So in the feedback block, if you observe carefully, we are having feedback block. This feedback block is going to give you the transfer function which is having only denominator. That denominator indicates pole, so it represents pole. So it represents pole. Okay. So this is what it is. So directly by seeing this block, we have to write what is the transfer function. Directly by seeing this block, we have to write what is the transfer function. How we can write? Let's say first, if I say B naught plus B1 S plus B2 S square, that's what it is. So because it is a forward path, we don't have to change the sign. Whatever the sign we are having, that sign we have to take. But it is a forward path, no change in the sign. Whereas it is a feedback path, or we can say backward path. So in this reverse path, what we have to take? We have to change the sign. In the reverse path, we have to change the sign. What do you mean by that? So let's say 1, then it is having a minus sign. So plus A1S plus A2S square. That's what we have to write as a denominator. Is that clear? So I can say this is numerator, forward block creates numerator, and feedback block creates denominator. Okay. First take down this somewhat in the side, not in the main one. Okay, this is not actually what we are going for, because this is what we have seen in the continuous time case. Then by comparing this, we can go for the direct form one. So that is in the discrete time case. So first you can take this as a continuous time case somewhat in the side, so that we will never let's come back. Okay. So direct form one, how we can say? Let's say a transfer function is given like this, h of z, which is, let's say, b0 plus b1 z inverse plus b2 z power minus. This is the transfer function numerator, and we are having a denominator 1 plus a1 z inverse plus a2 z power minus a2 z power. So we are having both numerator as well as denominator. So what we can do is, we can take them into two transfer functions. One is like this, b0 plus b1 z inverse plus b2 z power minus 2. This is a one transfer function multiplied with 1 by 1 plus a1 z inverse plus a2 z power minus 2. So this is another transfer function. I can call this is h1 of z multiplied with h2 of z, multiplied with h2 of z. So two transfer functions are getting multiplied to get the overall transfer function means these two systems which are in cascade, h1 of z, h2 of z. If they are cascade, then what is the overall system transfer function? That is nothing but h1 of z multiplied with h2 of z. So let's say now, to realize this h1 of z, which block we have to use? That is nothing but the forward block, because it is a numerator. To realize h2 of z, that is nothing but denominator, we have to use the feedback block. So this is realized by forward block, and this is realized by feedback block. Feedback block. So whatever the block, it doesn't matter. Remember one thing, if it is a forward path, no sign change. If it is a reverse path, change the sign. Okay. Remember that one also. forward path, same sign, constant having same sign, constant, or we can say constant having same, coefficients having same sign. Okay, better, same sign, why to worry, you can understand, same sign. And if it is a reverse path, different, different. So first I will create forward block. That means I will create numerator part, then I will create the denominator part. So let's see how we can do this. So let's say first I am creating the forward block. So to get forward block, B1, and we are having Z inverse, Z inverse. Then we are having B, B naught, B1, next Z power minus 1. So this is the forward block. This is the forward block. So this block creates H1 of Z. H1 of Z. So directly you can see. So how can we write the numerator? B naught plus B1 Z inverse plus B2 Z power minus 2, because we are having the forward path. So that means we don't have the sign change. Whatever the sign we are having, that sign we have. So this is the one block. Next, if it is cascade with a feedback block, let's say this is 1, Z inverse minus A1 Z inverse minus A2 minus. Okay. So this is the H2 object. H2 object. I told you, whenever you see feedback block, that is going to represent denominator. So how can we write the denominator? 1 by 1. So because it is a reverse path, we have to change the sign. So A1 Z inverse, A2 Z power minus 2, because Z inverse is a Z inverse. So this is called as forward block and reverse, feedback block. So this is going to give you H1 object, this is going to give you H2 object. Finally, so what is H1 object? H object, here we are having X object, here we are having Y object. So what is H object actually? H1 object multiplied with H2 object. So can you write what is H1 object directly by seeing this block diagram? So you can say B naught plus B1 Z inverse plus B2 Z power minus. Next, H2 object 1 plus A1 Z inverse plus A2 Z power minus. Okay. So this is what it is, nothing but the transfer function. So this is what we have to. So first take down this, then we will write some more points regarding this. Directly, if a block having transfer function simply Z inverse. So if X of Z is given here, then what we are going to get here? X of Z into Z inverse. Suppose if I take inverse Z transform, that means X of n is there, then what we are going to get here is nothing but X of n minus 1. n minus. So I can simply say from x of n to x of n minus 1. So we got some delay, that to 1 unit delay. So I can say this Z inverse is nothing but unit delay element. This is called as unit delay element. Unit delay element. So whenever you see Z inverse, that indicates unit delay element. So if you want 2 units delay, don't ever say Z power minus 2, because we will go with a cascade connection of Z inverse and Z inverse. That is going to give you Z power minus 2. That is going to give you what we can say x of n minus 1, because we are having only one element, one unit delay only. That is nothing but unit delay element. I hope you understood. And sometimes there is going to be this kind of thing also. Suppose there is a triangular shape kind of thing they have given, and 5 is given. So remember, this is nothing but x of z, then it is a multiplication factor 5x. So these are, once we got this, I can say, see here, z inverse 2 delay elements, z inverse 2 delay elements. So if I ask to realize any transfer function in the direct form 1, how many delay elements are required? I hope you understood what I'm trying to say. To realize a transfer function by using direct form 1, how many delay elements are required? So in simple, to realize this numerator part, we require 2 delay elements. To realize this denominator part, we require 2 delay elements. In total, we require 4 delay elements. So in general, how can we say this? That means the degree of numerator is nothing but number of zeros. The degree of denominator is nothing but number of poles. I can simply say in the direct form 1, the number of delay elements are required is nothing but degree of numerator plus degree of denominator. In simple, number of zeros plus number of poles. Clear or not? So I am writing that point. So I don't have space here. Okay. Let's see. In direct form 1, number of delay elements is equal to sum of, or we can say sum of degree of numerator and degree of denominator, or we can say number of poles, sum of number of poles and number of zeros. Take it, number of zeros. Next, direct form 2. Direct form 2. In the direct form 2, what we will do is we can take the first block is denominator. That means we will take 1 by 1 plus a1 z inverse plus a2 z power minus 2 and b0 plus b1 z inverse plus b2 z power minus. This is what we are going to do. Let's see what is the advantage of direct form 2. See here, if I take first block, which is going to give you denominator, second block, which is going to give you numerator. So let's see. Can I simply say, because it is a linear system, I can exchange this block with this block? That means if I take this block and place it here, if I take this block and place it here, if I take this block and place it here, this Z inverse is going to be coincide. This Z inverse is going to be coincide. Clear or not? So in short, so let me draw the direct form too. If I interchange the blocks, interchanging the block, interchanging the block. By interchanging the block, it will look like this. First, I will take the second block. So how it is going to be? This is the forward block. Sorry, this is the feedback block. So first we have taken that. Next, I will take this block. So to take this block, already Z inverse we require. So it is already there. Why we have to go for the extra element? So I will manage with these elements only. That means let's take this is B0. Let's take this is B1. Let's take this is B2. So this is what the block diagram for the direct form. So if you observe carefully, the number of delay elements required there and here are very less. Compared to that, this is having delay elements are very less. So in short, how many delay elements are required? So if I say more number of zeros are there, so those many number of delay elements are required. If more number of poles are there, those many delay elements are required. So I can simply say maximum number of zeros or poles, zeros and poles, whichever is having the maximum number, that's what the delay elements are. Nothing. So number of delay elements is equal to maximum of degree of numerator, degree of denominator. Whichever is maximum, that's what we have. Or we can say maximum of number of poles, number of zeros. Okay, so this is what the direct form 2. Okay, so I hope you understood why direct form 2 is preferred than the direct form 1, because direct form 2 having less number of elements. Take it 9, continued with the Z-transform number. This is the electronics 2015 question. The realization of a stable discrete time LTA system is as shown. Is as shown. If x of n is equal to u of n, then y of n is y of n. So try to understand. They have given block diagram x object, y object, and they have given x of n, and they want to find out y of n, and they have given one clue also, stable LTA. So first find out h object, that means transfer function. Transfer function is equal to y of z by x of z, that is h of z. How much h of z is equal to? So let's see. First, forward block is used for the numerator. So we are having z inverse minus 5 by 3. So because it is a forward path, we don't have to change the sign. Same sign we have to take it. So it is nothing but minus 5 by 3 z inverse here plus 5 by 3 z power minus z power minus divided by. For a numerator, we have to consider the feedback block. So here it is a forward path, so it is 1. Because it is a reverse path and having 1, so we have to take minus z inverse plus 2 by 9 z power minus. So this is what h of z we got. So just me write in terms of z so that it is going to be simple. If I do that, minus 5 by 3 z plus 5 by 3 by z square minus z plus 2 by. So if I take minus 5 by 3 common out, so here we have taken z square common, so here we have taken z square common, so sorry, z power minus 2, z power minus 2, they get cancelled. Finally we got this kind of expression. So if I take minus 5 by 3, that is z minus 1. Now what are the factors for this? What are the factors for this? This is nothing but 2 by 3, 1 by 3, 2 by 3, 1 by 3. So if I take minus for 2 by 3, that's it. So it is nothing but z, what we can say, plus 2 by 3, sorry, minus 2 by 3 z minus 1 by plus 1 by 3. Or do we have anything? No. So it is minus. Yes, minus. Yeah. Okay. So this is what the thing what we got, h of z. Now I want to get y of n. So for that, first we have to see what is x of z. X of z multiplied with h of z. So what is x of n they have given? X of n is equal to u of n. So from this we can say what is x of z? 1 by 1 minus z inverse, or we can say z by z minus 1, z by z minus 1. So what is y of z? Y of z is equal to x of z multiplied with h of z. X of z, that is z by z minus 1 multiplied with h of z, minus 5 by 3 into z minus 1 by z minus 2 by 3 z minus 1 by 3. So here z minus 1 get cancelled. Finally we are left with z into minus 5 by 3 by z minus 2 by 3 into z minus 1 by Now we have to do the partial fractions for this factor only. We don't have to worry about this z. Why? I told you in the Z transform, this z will be used later to write them in standard form. So what is the partial fractions for this? Z into 5 by z minus 1 by 3 minus 5 by z minus 2 by z minus 2 by. So finally, if I bring this z outside, so we are going to get 5 by 1 minus 1 by 3 z inverse minus 5 by 1 minus 2 by 3 z inverse. 2 by 3 z inverse. So for this we have to write the inverse Z transform. First we have to understand what is the ROC here. Why we have to worry about the ROC? Because it is given stable LTI system. For a stable LTI system, ROC must include unit circle, right? ROC must include unit circle means, let's say, suppose we are having 1 by 3 pole, 2 by 3. This is 1 by 3. This is 2 by 2 by. Then we have to consider ROC which must include unit circle. Then this is going to be right sided signals only. Yes, definitely we have to write the right side signals only. So then what is y of n? 5 into 1 by 3 whole power n u of n minus 5 2 by 3 whole power n u of n. Right side signal I have to write. Here, take it. The poles of the system transfer function are option 2, 3, 1 by 2, 3, 1 by 2, 1 by 3, 2, 1 by 2, 1 by 2. So for this system, we have to calculate the transfer function. In the transfer function, what are the poles we have? Okay. Listen here. So if you observe carefully, it is not the direct form 1, it is not the direct form 2. Then what we have to do? Then it is going to be very simple. What we have to do is start from y of z. This is y of z. Then what we are going to get here? Y of z into z inverse y of z into z inverse. Then what we are going to get here? 5 by 6 y of z into z inverse. Now what I am going to get here? Y of z, z inverse into z inverse. That is nothing but z power minus 2 multiplied with minus 1 by 6. So minus 1 by 6 y of z, z power minus. Next, what we are going to get here? This is x of z minus 1 by 6 y of z, z power minus. If these two getting added, that is going to be y of z. So in short, what is y of z? Is equal to, this is a 5 by 6 y of z, z inverse plus x of z minus 1 by 6 y of z, z power minus. So simply find out h of z. So for that, first take y of z one side. Y of z, if you take common, 1 minus 5 by 6 z inverse plus 1 by 6 z power minus 2 is equal to x of z. So what is h of z? That is y of z by x, which is 1 by 1 minus 5 by 6 z inverse 1 by 6 z power minus. So for this, if you factorize them, then we are going to get 1 by 1 minus 1 by 2 z inverse 1 minus 1 by 3 z inverse. This is the factorization. So what are the poles here? 1 by 2, 1 by. Clear, Anna? Take it.